So let me do inverse trigonometry miscellaneous exercise. The last sum in the old textbook is 17th sum. Tan inverse of x by y minus tan inverse of x minus y by x plus y. That's the question. You know that this should be treated as x and this should be treated as y. So just do tan inverse of tan inverse of x minus tan inverse of y, which is tan inverse of x minus y by 1 plus xy. Substitute that formula, x minus y by 1 plus xy. Substitute this, just try to solve this. Let's take an LCM, y into x plus y. So there will be x square plus xy minus xy plus y square. And then similarly take LCM for the denominator also. It's xy plus y square plus x square minus xy. The denominator get cancelled. This itself is tan inverse of x square plus y square by x square plus y square, which is again tan inverse of 1. Where will you get 1 in which angle? Pi by 4 in tan. Let's go to 16th sum. Sine inverse of 1 minus x minus 2 sine inverse of x is equal to pi by 2. The moment you see pi by 2, it's a solved sum. Okay, so take this sine inverse to the other side. 2 sine inverse of x is equal to pi by 2 minus sine inverse of 1 minus x. Identity. So that this will become a cos inverse of 1 minus x. Because pi by 2 minus sine inverse is cos inverse. Then bring, you don't want this 2 sine inverse. So make sure you're writing sine inverse of x is theta by 2. Sin theta by 2 becomes your x. And just substitute here minus 2 into theta by 2 from this. You get cos inverse of 1 minus what is x? Sin theta by 2. Substituting from this box. Bring the cos inverse to the other side. It will become cos of minus theta, which is cos theta, is 1 minus sin theta by 2. Then you have to use the third cos to theta formula. Third, which is 1 minus 2 sin square theta by 2 is 1 minus sin theta by 2. There's something that you will not know if you don't know the three formulas of cos to theta, which is cos square theta minus sin square theta, 2 cos square theta minus 1, or 1 minus 2 sin square theta. So you have to use one of this. But this 2 theta, this becomes theta, but here it's theta, so it will become theta by 2. I'm using the third formula. 1 and 1, minus and minus gets cancelled. It's 2 sin square theta by 2 minus sin theta by 2 is equal to 0. The sin theta by 2 can be taken out. 2 sin theta by 2 minus 1 is equal to 0. Therefore, you have two solutions. Sin theta by 2 is 0 and sin theta by 2 is 1 by 2. You substitute these answers, which is nothing but x, no? Which is nothing but x. X is equal to 0 and x is equal to 1 by 2. This will be not applicable. You substitute in the question and see. X is equal to 0 will be applicable. When you substitute a sine inverse of 1 minus 0 is sine inverse of 1, which is pi by 2. Minus 2 sine inverse of 0 itself is 0. So you get the answer. When verifying, you notice that one of the solutions, that is only x is equal to 0, will be applicable. The other solution will not be applicable. So let's go to next question in reverse. The 15th question, sine of tan inverse of x. We always need sine of sine inverse, and the best way to convert a tan inverse into sine inverse by drawing a triangle, writing x and 1 opposite by adjacent and root of 1 plus x square. So it's sine of sine inverse of opposite by hypotenuse x by root of 1 plus x square. This and this get cancelled, so you can mark D option D is the answer. So let's go to next question, which is the 14th sum. A tan inverse of 1 minus x by 1 plus x is half tan inverse of x. This is a solved sum where you have to use the right hand side also. The moment you look at it, you should consider this as x minus y by 1 plus xy. That's the way it is. It's tan inverse of x minus tan inverse of y. In this sum, what is x? X is 1. This sum, what is y? Y is x. So tan inverse of 1 minus tan inverse of x. The left hand side has become like this. And the right hand side, you still have half tan inverse of x. You have to take the right hand side because it's a solved sum. Bring it to the other side. A tan inverse of 1 is 3 by 2 into tan inverse of x. A tan inverse of 1 is pi by 4 because 45 degree is when tan will be 1. 3 by 2 tan inverse of x, and this get cancelled. A tan inverse of x is pi by 6. A tan pi by 6 is x. A tan 30 is nothing but 1 by root 3. 1 by root 3? Yes. So that's your answer for this question. So let's go to the 13th question, which is 2 tan inverse of cos x is equal to tan inverse of 2 cosecant x. When you have 2 tan inverse, you always need to convert into 1 tan inverse. A 2 tan inverse of x is tan inverse of 2x by 1 minus x square. 1 minus x square. Where x, in the place of x you have cos x. So tan inverse of 2 cos x by 1 minus cos square x is tan inverse of 2 by sin x. 2 cosecant x is 1 by sin x. Tan inverse get cancelled. 2 and 2 get cancelled. This is cos x by sin square x. And 1 by sin x, these two get cancelled. You get cot x is equal to 1. This happens when x is equal to pi by 4. So let's go to 12th question. And 9 pi by 8 minus 9 by 4 into sin inverse of 1 by 3 is 9 pi by 4 into sin inverse of 2 root 2 by 3 is a solve. No, it's a prove that sum. You take the left hand side. See what is common. You have 9 by 4 common. You get pi by 2 minus sin inverse of 1 by 3, which is an identity in inverse trigonometry, which is 9 by 4 into cos inverse of 1 by 3. But in the right hand side, you have answer in terms of sin inverse. No problem. Draw a triangle. Put 1 on the adjacent side, 3 as the hypotenuse. You get a root 8, which is 2 root 2 on the opposite side. So you can convert the cos inverse into sin inverse, which is opposite by hypotenuse. And you got what you really want. So let's go to 11th question, which is tan inverse of root of 1 plus x minus root of 1 minus x by root of 1 plus x plus root of 1 minus x is equal to pi by 4 minus half cos inverse of x. This sum is a prove that sum. You have to take the left hand side and solve. The moment you have 1 plus x, 1 minus x, and so complicated, so you know you should substitute x as cos theta. Tan inverse of root of 1 plus cos theta minus root of 1 minus cos theta by root of 1 plus cos theta plus root of 1 minus cos theta. Then theta is actually cos inverse of x. Correct? So tan inverse of 1 plus cos theta is 2 cos square theta by 2 with a root. A 2 sin square theta by 2 by root of 2 cos square theta by 2 plus root of 2 sin square theta by 2, which will become tan inverse of root 2 throughout get cancelled, root and square get cancelled. A cos theta by 2 minus sin theta by 2 by a cos theta by 2 plus sin theta by 2. The tan inverse of 1 minus tan theta by 2 by 1 plus tan theta by 2 by throughout dividing this format by cos theta by 2 in the bracket, you get and this itself is tan pi by 4 minus theta by 2 with a tan inverse. Tan inverse tan get cancelled. What is theta in this sum is cos inverse of x. So pi by 4 minus cos inverse of x by 2, and that's your answer. So that's completes that question. So let's go to 10th question. A cot inverse of root of 1 plus sin x plus root of 1 minus sin x by a root of 1 plus sin x minus root of 1 minus sin x. A cot inverse of, you know what is 1 plus sin x formula? Is cos x by 2 plus sin x by 2 the whole square. Is cos x by 2 plus sin x by 2 the whole square. And 1 minus sin x is cos x by 2 minus sin x by 2 the whole square. When you put it in roots, root and square get cancelled, become cos x by 2 plus sin x by 2 plus this is cos x by 2 minus sin x by 2, this one, okay, by a cos x by 2 plus sin x by 2 minus cos x by 2. A minus sin x by 2 will become plus sin x by 2. Cos and cos get cancelled, sin and sin get cancelled. A cot inverse of 2 cos x by 2 by 2 sin x by 2, which is cot inverse of cot x by 2. So the answer itself is x by 2. And that's exactly what they would ask you to prove. In this question, they would have specified the x is lying between 0 and pi by 4. Because um, the thing that I would like to tell you is a 1 plus sin x can be written as a cos x by 2 plus sin x by 2 the whole square, or 1 minus sin x in other words. Let's see. A root of 1 minus sin x is there. Inside root, negative cannot come. It should be positive values. So 1 has to be always greater than or equal to sin x. So sin x has to be always lesser than or equal to 1. When will sin be 1? So sin will be 1, okay, when it is 90 degrees or less than 90 degrees. So you know that for this has got to be in first quadrant. But they've given 0 to pi by 4 in this sum. Let's explore more on this. When you write this as, the moment you write it as cos x by 2 minus sin x by 2 the whole square, see, when you substitute a value such as a 60 degree, which is beyond this 45 degree value, it will become cos 60 minus sin 60. And what is inside the root can never become negative, okay? Cos 60's value is what? Cos 60 is 1 by 2 minus root 3 by 2. Obviously, you're getting a negative answer here. See, when you are trying to, a square root function's value should always be positive according to relations and functions. Okay, in the functions, you should understand a square root function's value should always be positive. And if you substitute this, and also when the root and square get cancelled, but it cannot have negative value, right? So you should understand that this has to lie only between 0 and pi by 4. If it is pi by 4 to pi by 2, then you will write 1 minus sin x as sin x by 2 minus cos x by 2 the whole square. Think of this, root and square get cancelled. Let's see. Sin, supposing here some example, sin 60 minus cos 60. What is sin 60? A sin 60 is root 3 by 2. A cos 60 is cos 60 is 1 by 2. You're getting a positive answer. This is okay. So depending on the interval, something that this extra that I'm teaching you here, people who can follow, otherwise later I'll explain. When it is lying between 0 and pi by 4 as given in the question, it's fine. You can write it as, because a cos 45 minus sin 45 is 0. 0 is possible. Okay, or it has to be positive value. So you should always write it as cos x by 2 minus sin x by 2 the whole square for root of 1 minus sin x. And for root of 1 minus sin x, when the interval is between pi by 4 to pi by 2, you should write it as sin x by 2 minus cos x by 2 the whole square. By root and square then can cancel. This is something you got to remember. Okay, I'll recall this whenever I teach you in the class also. So whatever we have written is correct, because according to the question, x is lying only between 0 and pi by 4. It's perfect. So it's perfect. Okay, so let's go to next. The next question is the 9th question, where it's tan inverse of root x is half of cos inverse of 1 minus x by 1 plus x, where x is lying between 0 and 1. Okay, which means x is not negative. Okay, so then that's fine. Because obviously this root x and root x cannot be negative. No? That's what is this explanation. You can forget about it and solve the sum. In this, I'll go from the right hand side because I want the cos inverse of cos so that it can get cancelled, for which I have to substitute x as tan square theta. A tan theta is root x. A theta is tan inverse of root x. So that it will become, this will become 1 minus tan square theta, a cos inverse of 1 minus tan square theta by 1 plus tan square theta, which is cos inverse of cos 2 theta. There's a half which exists and half and 2 get cancelled, which is just theta, which is nothing but tan inverse of root x. So you get whatever the answer that's there. So let's go to the next question. An 8th question is tan inverse of 1 by 5 plus tan inverse of 1 by 7 plus tan inverse of 1 by 3 plus tan inverse of 1 by 8. You have to prove this to be equal to pi by 4. You club this as tan inverse of x plus tan inverse of y. Club this as tan inverse of x plus tan inverse of y. Get tan inverse of x plus y by 1 minus xy plus tan inverse of x plus y by 1 minus xy. And again solve this completely. 35, 7 plus 5 by 34, which is tan inverse of 12 by 34 plus tan inverse of 8 plus 3 by 23 is tan inverse of 11 by 23, which is again like a tan inverse of x plus tan inverse of y. Do tan inverse of x plus y by 1 minus xy. When you substitute that, you get tan inverse of 1, which means the answer will obviously be pi by 4. So let's go to 7th question. A tan inverse of 63 by 16 is equal to sin inverse of 5 by 13 plus cos inverse of 3 by 5. The best thing that I can do is to just draw a triangle, right? 3, 5 opposite, hypotenuse 13. So this will be 12. This again 3, 5 adjacent hypotenuse. So it will be 4. Let's write it as tan inverse of 5 by 12 plus tan inverse of 4 by 3. Select tan inverse of x plus tan inverse of y of 5 by 12 plus 4 by 3 by 1 minus 5 4s are 20, 12 3s are 36. Solve this. You will get this as the answer. Directly tan inverse is the answer. So let's go to next question, a 6th question, which is cos inverse of 12 by 13 plus sin inverse of 3 by 5 is sin inverse of 56 by 65. Draw a triangle 12, 13, so obviously this is 5. Draw a triangle 3, 5, obviously this is 4. So then this is 5 by 12, tan inverse of, convert them. Is tan inverse of 5 by 12 plus tan inverse of 3 by 4, which is like tan inverse of x plus tan inverse of y, which is tan inverse of x plus y by 1 minus xy. You solve this, you get the answer in terms of tan inverse. 48 will be the LCM. 5 4s are 20 and 12 4s are 40, 12 3s are 36. 48 minus 15 is 35. So you get tan inverse of 56 by 35. But your answer is in terms of sin inverse. Just don't hesitate, just draw a triangle opposite 56 adjacent 35. You write this as 65 directly. You have a 56 already. Cool man, sin inverse of 56 by 65 is your answer. So let's go to, so I am pretty sure you can do all these sums easily. I'll do the third sum. 2 sin inverse of 3 by 5 is tan inverse of 24 by 7. I'll draw triangle opposite hypotenuse, this 4. 2 tan inverse of 3 by 4 is like 2 tan inverse of x, which is tan inverse of 2x by 1 minus x square, which is tan inverse of 6 by 4 minus 7 by 16, 24 by 7, a tan inverse. We got the answer. So let's go to second sum, which is tan inverse of tan 7 pi by 6. Tan inverse of tan a pi plus pi by 6, which means we are solving only the trigonometry, and pi plus is in the third quadrant, so it's positive at tan pi by 6. Now bring the tan inverse down. The answer is just pi by 6. So solve the trigonometry and then do the inverse trigonometry. A cos inverse of cos 13 pi by 6. Solve the trigonometry. Cos 2 pi plus pi by 6 is either pi minus pi plus 2 pi minus 2 pi plus. So what works here is 2 pi plus. It's the first quadrant. 2 pi plus is in the first quadrant. It's cos pi by 6, right? Yeah. And a cos inverse can be brought down, and so the answer is simply pi by 6. There's no negative argument or anything here. So that was easy. So let's go to example 13. Example 13, a tan inverse of 2x plus tan inverse of 3x is equal to pi by 4 is a solved sum. It's like tan inverse of x plus tan inverse of y, which is tan inverse of x plus y by 1 minus xy is equal to pi by 4. Take the tan inverse to the other side. So you get a quadratic equation, a 6x square plus 5x minus 1 is equal to 0. You get, on solving this, you get 6x minus 1 and x plus 1 is equal to 0. So x is equal to 1 by 6 or x is equal to minus 1. On substituting this in the question, x is equal to 1 by 6 will be the right answer. This will be not applicable. You try to substitute, and verification is very, very important. So let's go to example 12. In example 12, which shows tan inverse of a cos x minus b sin x by a b cos x plus a sin x. Okay, and the moment you see such a simplification sum, you will divide it throughout by b cos x. So tan inverse of a by b by minus tan x by 1 plus a by b tan x. And this is similar to x minus y by 1 plus xy. So it's tan inverse of x minus tan inverse of y. In the place of x you have this, in the place of y you have this. So then it's tan inverse of tan x, and this get cancelled. The answer is tan inverse of a by b minus x. Simply this is the answer. So let's go to 11th example. Example 11, where show that a sine inverse of 12 by 13 plus cos inverse of 4 by 5 plus tan inverse of 63 by 16 is equal to pi. So draw a triangle. This is opposite 12 hypotenuse 13, this will be 5. And this is adjacent 4, and this is 5, and so this will be 3. It's tan inverse of 12 by 5 plus tan inverse of 3 by 4. Keep this separately, we'll solve it later. Tan inverse of x plus y by 1 minus xy, which will become a tan inverse of 20 is LCM. 12 4s are 48, 5 4s are 20, so 5 3s are 15 by a minus 16, which is tan inverse of 63 by minus 16, which is negative argument. You know, cos, secant and cot only is pi minus. This is just minus tan inverse of 63 by 16. And in bringing this third term directly down now, you get answer as 0. But you are supposed to get answer as pi. Therefore, what you do, you write the third term here and consider this as x plus y plus z. X plus y plus z, we got it as 0. Take the z to the other side. Insert a tan on both sides. And tan of x plus y is, you can write it as tan minus tan z. Tan of minus z is minus tan z. Tan x plus y is tan pi minus z, because you know a minus can be got even in the second quadrant. Somehow I'm inserting a pi, so that now if I do x plus y plus z, I'll get a pi, and that's what I need to prove. So that completes example 11. Very tricky sum. Okay, I'll do example 9 because that's 10 is a similar sum, so I'm skipping that sum. So example 9 is sine inverse of sine 3 pi by 5. I'm going to solve only this sine pi minus 2 pi by 5. I told you it's either pi minus, pi plus, or 2 pi minus, or 2 pi plus. So this works here, and it's the second quadrant where sine is positive. So sine 2 pi by 5, bring the sine inverse. So answer is 2 pi by 5. So the rest of the sums I have already provided you with a video. Please ensure you are thorough. This is the textbook sums. Okay, miscellaneous. So I'll write it here. Inverse trigonometry, miscellaneous, exercise, miscellaneous examples and exercise. Okay, and I'm going to name it 2026.